Graph and polynomial functions. We can use what we have learned about multiplicities and behavior and turning points to sketch graphs of polynomial functions. Let us put this all together and look at the steps required to graph polynomial functions. Given a polynomial function, sketch the graph. Number 1, you want to find the intercepts. Number 2, check for symmetry. If the function is an even function, its graph is symmetrical about the y-axis. That is, f of negative x is equal to f of x. If a function is an odd function, its graph is symmetrical about the origin. That is, f of negative x is equal to negative times f of x. Number 3, you use the multiplicities of the zeros to determine the end behavior of the polynomial at the x-intercepts. Number 4, determine the end behavior by examining the leading term. Number 5, use the end behavior and the behavior at the intercepts to sketch a graph. Number 6, ensure that the number of turning points does not exceed one less than the degree of the polynomial. And number 7, optionally, use technology to check the graph. So we're going to sketch the graph of the polynomial function. We're going to sketch the graph of f of x is equal to negative 2 times x plus 3 squared times x minus 5. Now this graph has two x-intercepts. We can see one at x equals negative 3. The factor is squared. Let me highlight that. So we have an x-intercept at negative 3. And we can see that the factor is squared, indicating a multiplicity of 2. So what does that mean? That means the graph will bounce at this x-intercept. Another x-intercept here, x minus 5, would give us x equals 5. And it has a multiplicity of 1, so the function has a multiplicity of 1, indicating the graph will cross through the x-axis at that intercept. So the next step is we need to find the y-intercept. And the y-intercept is found by evaluating f of 0. F of 0 is going to equal negative 2 times 0 plus 3 squared times 0 minus 5. So we get negative 2 times 9 times negative 5, which gives us 90. So the y-intercept is located at 0, 90. So we're going to want to plot that on our graph. And then the x-intercepts are found by setting f of x equal to 0. So here's our function, negative 2 times x plus 3 squared times x minus 5 equals 0. If we divide by negative 2, then here are our x-intercepts, which we've already determined from step 1, but we got x plus 3 squared equals 0, so again x equals negative 3 with a multiplicity of 2, and x equals 5 with a multiplicity of 1. Now in step number 3, additionally, we can see the leading term, if this polynomial were multiplied out, would be negative 2x cubed. So the end behavior is that of a vertically reflected cubic, with the outputs decreasing as the inputs approach infinity and the outputs increasing as the inputs approach negative infinity. So since the leading term is negative and it's an odd degree, then we're going to know that it's going to rise on the left and it's going to fall on the right. So therefore that's just given us this particular graph in figure 13. Now, to sketch this, we need a couple of things of information. Okay, we said again here, as x approaches negative infinity, the function is going towards positive infinity. So we know the graph starts in the second quadrant and is decreasing towards the x-axis. So if we plugged in negative x into the function, okay, if we plugged in negative x, it's not going to equal f of x. So therefore the graph does not display symmetry. And then at the value, negative 3, 0, the graph bounces off the x-axis, so the function must start increasing. At 0, 90, the graph crosses the y-axis and the y-intercept. So let's take a look here. So here we plotted our x-intercept, negative 3, 0. So that means when it comes down here, it's going to bounce off the x-axis, and then it's going to go back up to where it is at 0, 90 from where the x-intercept is. Now after this point, then the graph must turn back down or start decreasing towards the horizontal axis because the graph is passing through the next intercept at 5, 0. So what that means is we should have the following. So again, this graph isn't going to be exact, but we know it's going to come down towards this direction. It's going to bounce back up and go towards the Y-intercept, okay, in figure 14. And then in figure 15, okay, again, so we're going to come down here, we're going to bounce off of that x-intercept, and then it's going to come back up here and then go back through the next intercept, which is 5, 0. Because as x approaches positive infinity, we know the function is going towards negative infinity. So then, what do we know about turning points? Well, we know the degree of the polynomial is 3. So 3 minus 1 gives us 2. So there are at most 2 turning points. Well, here's one turning point. Here's a second turning point. Now, to verify, we can graph this function, and we can create the graph of the polynomial function as shown. So you can see here, here's our graph. It's going down towards negative 3. It bounces back up, goes through the y-intercept at 0, 90, and it comes back up and has another turning point, and then goes through the x-intercept of 5, and it keeps going down.